you. Oh, Trent, oh my God, you're way ahead of me. Amazing. I'm so
No,
sorry
what do you
about...
want to talk about?
I was just going to say, I'm sorry about the feedback, but I just want everybody here to understand that feedback loops are bad, both in an AV sense and a climate sense.
We're really doing it. We're going there.
Trent and I were at Google, and they always say there that feedback is a gift. And they were wrong about that. I asked Gemini, and it said that that was wrong. So I want to hand over here to Lynn.
Hey, everybody. Thank you, though there's going to be more clapping for much more impressive people in just a second here. My name is Lynn Stoller. I'm the Climate and Policy Lead here at Impulse Labs. You are going to hear more about Impulse Labs throughout the day, and I'm sure that you've heard about us a little bit so far. So instead, I'm going to take a second to also acknowledge one of the major sponsors of today's event, which is the Abundance Institute. Yes, we are huge fans. The Abundance Institute is a very, very recently launched public policy nonprofit that is working on helping to bridge the gap between today and a more positive, optimistic, and abundant vision for the future. We have their team here today. I'm just going to point out Chris in the back there. And so, yeah, if that's something that excites you, you should talk to one of the Abundance Institute folks. So for this discussion, they are like a particularly relevant topic to bring up because the Abundance Institute focuses on distributed energy and AI as two of their policy focuses. And this discussion is all about how planetary scale load shifting happens. This is particularly important in the context of the increased energy demand associated with AI that we're seeing. And for that discussion, we have Eli Dorado, who is the chief economist at the Abundance Institute and will be moderating. Come on up. And we also have Peter Fried, who is the former director of energy strategy at Meta and now advises companies like the ones here today on how to meet that planetary scale load shifting. And we have Jen Huffstetler, who is the chief product sustainability officer at Intel. I will leave it to them to take us forward.
Thank you, Lynn. It's great to be with you all here today. We have a great panel. They have each have 20 years or more of experience in their respective fields, so we're lucky to have Jen and Peter with us here today. So I wanted to start out by setting a little bit of context. Like right now, the U.S. is about 1.3 terawatts of electricity generating capacity. Thinking about growth over the next 20 years or so, like how much capacity do you think we're going to need? What do you think the sources of that load are going to be, like between like compute and AI versus electric vehicles versus heating versus industry as we electrify? Like, set the context for us. Like, let us know like how big is it going to get, and what are the sources going to be?
Yeah, I mean, I think there's been a lot of conversation lately about AI and the electrical loads associated with it. I think everybody's probably seen some of the headlines on that. I think, in a sense, that's a little bit of a distraction. We've spent the last, call it 18 months of policy cycles passing a lot of legislation designed to electrify as much as humanly possible. It's like a core part of the climate strategy for the current administration. And so, we're seeing industrial electrification, we're seeing transportation electrification, residential, mobility. Yeah, compute is certainly part of that, but it's not the only part of it. And it's what we wanted to happen. So this is great. And on top of that, when it is happening, for the most part, it's representing economic development and job creation, which is also amazing. So I think we are in a moment of tremendous opportunity. I am hoping that maybe the narrative externally can shift a little bit. We can start recognizing how exciting it is to see all of this load coming onto the system. And simultaneously making sure that that load is decarbonized and reliable and affordable for customers of all types. But to specifically answer your question, a lot. I think ultimately what we are after is trying to figure out how much we can electrify. So ultimately the true answer in terms of terawatts is really a measure of how successful we are at what we're pointing ourselves at.
Thanks. I think that's a great introduction, Peter. And just to add to that, I think there's going to be these new sources of clean energy. We certainly have the solar, the wind solutions today, hydropower. Where I'm from in Oregon, we use that to powered data centers and beyond. But everybody is looking for how do they deploy more dense solutions to meet these increased needs. And so I really think that is a new opportunity in the market for, crossing the chasm on how we meet these needs. Because, when we, and I'm sure, Peter, you know so much better than I do, you can't always bring the utility-based load online as fast as you want. And it takes a long time to get the access there. And so it's going to take investments across the industry to help us cross that chasm, to get some of these newer technologies there and accessible. And some of them might not be the cleanest, right? I think, natural gas we're going to see is being deployed in more places in the near term, while some of those technologies are making their way to full commercialization and lower price points. But, in general, yeah, we're going to be seeing it everywhere. We can talk a little bit more about how much will it be growing in the different places. It's growing overall. That's been our history for 1,000 years, more energy over time.
Great, so we're here at Impulse Labs, an event co-sponsored with Harvest. These are both companies that do load shifting at the sort of the household level, working on data centers and compute facilities. You guys have the opportunity to think about load shifting on much bigger scales, like maybe even a planetary scale, given the distribution of load centers. So, so what can be done? What are the tricks that we can do to do load shifting, maybe help stabilize the grid, et cetera, when we're thinking about data centers?
Sure. I can take a start. Actually born out of high performance computing, right? A lot of what you're going to be seeing with artificial intelligence, the workload looks fairly similar, and you're able to, have higher priority jobs, lower priority jobs. You can pause the work, and in a lot of cases, training that model, which is the more energy intensive portion, right? The inferencing's happening all around, but that more, centralized, dense energy consumption on the training, it's typically not urgent that it happens now. So that's like a technique that actually some of the largest cloud providers here in the Bay provide when they're in partnership with Silicon Valley Power, others, to help make sure that everybody who's sharing in the cost of the capital, right, to, receive that power, they're able to avoid blackouts, or the extent that they can. I think there's more needed in that demand supply communication, and there's probably, some software techniques and even artificial intelligence and communication between, the demand side and the supply side. I think absent policy, it's probably not going to happen at the scale that it could. And then when you talk about planetary load shifting, I think, certainly you see Google has been certainly a thought leader in this. They've published a lot of white papers about how they're moving the load to, follow the sun, where it's going to have the greenest energy. I think what we're going to see moving forward is, while that's certainly a possibility, it's pretty complicated for those that aren't the most savvy, right? I mean, you're talking about these hyperscale data centers that we talk about. They're running a major application like search or your Instagram, et cetera. They have technical capabilities that most of the world doesn't have. So while they'll continue to employ that, I think what we're going to see is more of what I talked about first, is how am I being intentional in my energy consumption if I'm an enterprise or somebody, with less of a load than that.
I might just sort of build on that, because I think that's a great explainer on what folks are doing now. I also think that it's actually worth sort of unpacking what we mean when we say load shifting, because ultimately we're not really talking about energy in most cases. We're thinking about capacity and constrained moments, and historically things like peak shaving or the types of things that maybe folks at Impulse are thinking about, great, important. But there are also a lot of things when you start thinking about servers and batteries inside of data centers. The backup batteries inside of data centers are the largest energy storage installations on the grid today, and they have been for decades. What if you made those responsive to grid operators? So, you can be providing frequency, you can be providing millisecond response. Like, there's a bunch of things that we can be doing that move beyond just like, hey, we're going to use less in certain hours, to how do we provide a suite of services that grid operators need. And those don't necessarily just look like energy or capacity, they look like other things. And I think, historically, this has largely been sort of a voluntary conversation. If you look at what's happening in certain markets in Europe, like, I'm not sure it's going to be voluntary for that much longer. Understanding how you can have more flexibility in terms of how large-scale loads are operated, ultimately maybe being part of the equation if you want to get interconnection capacity.
What about actually engineering the product to be more efficient? Like, what is the role there? So I'm thinking about like just chip efficiency or data center design and so on. Like, I'm sure you've worked a lot on that. Can you give us your thoughts?
I'm not an engineer, so this is all Jen.
Okay.
I'm excited to hear the answer to this one.
Well, the engineers you've been working with have been doing this. I think that's, there's a lot of sensationalist headlines you were talking about today, and I think a lot of what that's missing is the innovation that brought us here, to this era of cloud compute, and the innovation yet to come in the future. And so that's a lot of what we, at Intel, we work on, not just from the chip, but to the platform, to the system or rack, the pod, the cluster scale, the data center, the software that goes into that. There's optimizations at all layers of that compute stack. And so it's not just the chip, although the chip alone, our estimate from 2010 to 2020, had we not had any innovation, if we were still deploying in 2020 those chips from 2010, it would have taken 1,000 more terawatt hours just for the data center processors. So data center energy efficiency always has been happening as you ride Moore's Law, as you increase the density of compute on a chip. New technologies like virtualization technology, containerization, those are all things that are more cores. They're enabling server consolidation where you can replace 10 racks with one, right? And that has been happening over time. It's going to keep happening, not just in the general compute space, but then also in AI. So in the AI space, you've got model optimization that's happening. There are new data formats that are coming out. So going from 16 to 8 to 4. Microsoft has published a paper, 1.58-bit LLMs. As you reduce that data type, it reduces the amount of energy that's needed, the amount of calls to memory. So that's kind of like at an architecture level, but it's optimizing the model. You can optimize the algorithm and feed it. We all know the models need tons of data. 99% of it in one study shows that they're turning up zeros. So if you actually feed it less data, it's going to use less energy. So how do you take this sparsity approach? Those are some of the model side. On the optimization, software optimization side, this is actually what I call AI for sustainability. So the first piece is how do you make AI more sustainable? Better chips, better models, better software, liquid cooling, removing these chillers on the data centers that Peter is bringing the energy to. That's sustainable AI, but then you can also deploy AI for sustainability, right? Building management, we use it in our factories, right? To help us reduce even the test time. That means we're running fewer testers, and if you think about the carbon aspect too, that's less embodied carbon. If you need less testers, running less energy, and that can happen inside a data center. It can happen inside our mobile networks. So you think about, connecting your phone. Well, when the network uses AI to understand the mobile network traffic and the amount of IT energy consumption that's needed to provide you the service that you're expecting, they're able to modulate that power, and they can have 20% savings just by using AI to monitor and match the energy needs to the demand.
Yeah. No. Okay. Well, here's one that you'll probably have thoughts on, Peter. If we think about all the load growth that we're expecting, we talked about it. Is our grid ready for that?
No. No, the grid is barely ready for what we have today, it's been, call it 15 years of flat to declining load across the country. A lot of that actually is because we've been phenomenally successful at deploying energy efficiency into the built environment, which is awesome. But yeah, I mean, based on what we were saying, all of this new load is coming. And I think, you could either call it frantic, you could call it the Wild West, you could call it whatever you want to call it, but we have a lot of folks scrambling right now to figure out how to lock up sufficient capacity, electrical capacity, for what they want to do on the system. And no, we're really, really not ready for it, either from just like a what's available to how we use it. We're very inefficient in the way that we use our wires, we're very inefficient in the ways that we use our gen. And we are struggling to figure out how to deploy enough generating capacity to accommodate it. And I think, Jen alluded to this, like we are, there's a lot of talk right now where it's just like, all right, we're gonna deploy a ton of gas. Like that's gonna be what happens. We're gonna deploy a ton of gas and that's gonna how we're gonna solve this problem. True, some of that is certainly true. We're gonna have more gas. Personally, I would like to spend a lot of time thinking about how we have more gas, which is a conversation which is really interesting. But also, how do we bring other technologies to the mix, better utilization of existing infrastructure? Some of this is really dead simple stuff like dynamic line ratings. And then I think you get into some of these other questions about what does your gen stack look like for a clean energy future. We're looking at long duration storage, SMRs, advanced geothermal, like all of these different things. And it's probably an all of the above strategy that will take us through some period of time to get to a place where we feel happy and comfortable with a fully decarbonized generation stack. But no, like right now, I think it legitimately, we probably aren't ready. I will say, as I said before, like I don't think for the most part we have an energy issue. I think we are dealing with capacity issues in most markets. And so that at least is better than some of the alternatives. But nonetheless, like when it's a peak hour and you don't have sufficient capacity, like that's still a real problem.
Yeah. Is that my mic? I'm not sure what that is. Yeah. Building upon that, I think a portfolio is going. Is it this one? I don't know either.
Test.
Can you hear now? I'm sorry. I did not mean to bring my phone and cause interference. I was in AI Energy Summit just last week in DC. This is a huge topic, right? The DOE is really trying to figure out how do they not only get the funds to help support those clean energy technologies to cross that chasm, but what really are those demands that you were talking about, Eli? Where is it going? What can be done? There was I can't remember who said it or the source, but somebody said that if we just deployed the technology that we already have today to do some of the load balancing, to basically create a smart grid. We have technologies, but they're not being deployed today. And this is where I talk about, we need to find ways to reach the regulators who are protecting all of us, who are paying for that capital in our rates every day, but they don't understand the technology. So there's been technology solutions around for years. We have a consortia. You can't do anything alone when you're a chip maker. So there's software vendors, hardware vendors, network vendors, and we have a solution called the Edge for secondary substations. It helps to onboard more renewables to the grid, whereas you think about the grid up until now was a one-way load coming to your house, but now you're putting a load on or in a data center. How do we get that back to the grid? These technologies exist, but there's fear, uncertainty, and doubt about will that impact the resiliency of the grid, the reliability of it, the security of it, and that's probably one of those areas I took away last week that we really need to work on, is with this other set of constituents who are actually the decision makers about the grid. And the stat that they said last week was we could probably get 2x more effective capacity out of the current grid and generation today if we deployed those technologies. I'm newer to the energy space, but that was just mind-boggling that we have technologies and it's holding us back.
So in many parts of the country, something that the Abundance Institute thinks about a lot is interconnection queues, like to get new generating capacity on the grid. They're quite long. We also think a lot about permitting and other obstacles to like deploying new generation. So given that and other problems with the grid, distribution, et cetera, should data center projects be thinking about bringing their own generation capacity, either behind the meter, off-grid entirely? Like, what are the possibilities there, and what are you guys thinking about in terms of that, and what are the trade-offs?
I mean, I have very strong feelings on this, which is that I think we're going to see a lot of interest in doing behind-the-meter direct-fed projects. You know, the tech sector loves to disrupt things, like we love to change people's business models. This is not a sector which is particularly ripe for disruption, and actually I think it'd be very short-sighted to imagine that behind-the-meter solutions at the gigawatt scale are going to be an approach that serves anybody in the long run. The grid is very effective. I mean, the grid ultimately is, in spite of what I just said, you know, it's this like beautiful machine that's been running and on a millisecond basis, keeping things perfectly in balance, and has been doing so for a very long time. And power companies, for all of the bashing that people like to do with them, are actually pretty good at it. And so I think, you know, ultimately, if you are deploying data center capacity or anything else, the question you should be asking is not, do I bring my own generation? It's like, well, if it's on site or down the street or 1,500 miles away, can I plug the thing in and turn the lights on when I need to? And ultimately, my personal belief is that the power company should be part of that equation. I think some of the things that we are seeing in terms of like not deploying the newest technology and otherwise, there's no ill intent with any of this. It's just inertial, you know, like I won't name the utility, but one of the first projects I was doing, they were in the middle of an integrated resource plan filing when we were doing our own rate proceeding, and the integrated resource plan filing had to be delayed by 6 months because they could not find a computer which was old enough to run the software that they were doing their system planning with. They ultimately bought it off of eBay, but like, this is just like, this is stuff that we can fix, and you know the regulators are part of that equation. But ultimately, it's just it's making sure that we are working closely with the industry, figuring out avenues for engagement. I think if I had always assumed for at least a long time that if we had an idea that would work for a utility, they probably wouldn't want to deal with us on the software side. They're going to be looking to GE or ABB or somebody that's sort of deep there. But Amazon just did a really interesting project with Duke on power flow analysis. It wasn't even AI. It was just like very simple computational stuff that unlocked quite a bit of capacity. So like there is stuff that's starting to happen. So anyway, long answer to a short question, but I think working with the utilities and to the extent that we have direct fed stuff, those should probably look like bridges to a longer term grid connected supply rather than like permanent mega islands that are sort of sitting off to the side. Separate to the politics associated with trying to do that, which I promise you would not be good.
I think the challenge some of those operators are facing today is they don't see a line of sight to getting the capacity in the time that they need it. And they can, when they're building data centers, they're doing it today. It's going to live for 20, 30, 40 years. So I think folks are having to deploy some of that on-site behind-the-meter gen just to meet their immediate needs. But I agree with you, Peter, like it's best for everyone to have that resiliency, for them to be a committed partner. I think about the economic impact if you have one of your largest consumers now off the grid and not, an equal paying partner of the capital that was there already. What does that do? So I think you're going to see near-term deployments because they just need to meet their business needs. But long-term, we do need to find that two-way strategy.
So shifting into like the last part of the discussion, virtually everybody in the tech industry wants to scale AI data centers based on clean energy. Right? And it sounds like we all agree in the short term there'll be some natural gas. But what do you think what do you think the path is? Like short term, medium term, long term, and then how realistic is it to scale on clean energy? And then do you think that the demand from tech companies for data centers could help catalyze and grow new clean energy technologies. So like, I know that Google has done like a geothermal project with Fervo, for example, and several companies have done like deals now with nuclear startups and so on. So what do you think about that? Do you think that the tech industry can help drive progress in clean energy generation?
Sure, I'd be happy to. I think first and foremost, you're going to see new technology coming out, right? Like Intel's got accelerators. Is it my watch?
I don't know.
That are going to deliver, 50% more performance, 40% less power than the top leading accelerator on the market today. There's dozens of companies out there that are building new chips that will be more efficient, these algorithms. So that innovation is going to keep happening. I think there's also the opportunity, we pulled together our entire value chain, and if you don't know, Intel's now basically 2 effective companies, so we've got a foundry to build not only our chips, but any new or incumbent players, as well as the product side. So we had our sustainability summit a couple weeks ago, the entire value chain of the suppliers that help, make the machines to make semiconductors, customers, partners, and everybody agreed to align on an industry roadmap. Number 1 on that roadmap is clean energy. I think the projects that these individual players are doing is great, but I think there's more we can do together to help our supply chain and our value chain, which you start to think about where technology scales, that's planetary. Every sector, every industry. So I think in addition to the individual projects, that we can help to accelerate that transition together.
Couldn't agree more with all of that. I think we're in an interesting moment on a couple of fronts. First of all, with current technologies, without any technology innovation, we can still go to much higher penetrations of renewables on the system that we're at today. So we should just be plowing more renewables onto the grid in many places, wherever we can. So what is this new trajectory on load growth doing for us? I think at least 2 interesting things. One is that the interconnection queue problems that you talked about, some of these issues with transmission, deployment, permitting, et cetera, the system is not particularly responsive to generation. Utilities don't like generation that they don't own. It's complicated. The incentive structures aren't great. They're extremely responsive to load. And so one of the things that I hope we might see happening is that some of these things that have been very entrenched problems for the last 15 years may get unstuck because the economic engine that load growth represents can help drive innovation where competitive pressures historically haven't. So that's sort of one thing that I hope we'll see coming. Who knows? And then the other is this belief, at least that I have, this sort of playing off of what Jen said, which is historically we have been thinking about renewable energy solutions on a facility by facility basis, whether you're 24/7 or 100% renewable or whatever it is that you have. It's all right, I'm going to deploy this load, and then I'm going to go secure largely through PPAs or other contracts renewables for that facility. And we are now reaching a scale, at least for these large-scale data center developers, where I no longer think it is feasible to address those needs facility by facility, which is going to drive more incumbent players to think about decarbonizing the system as a whole. And the faster we can move towards getting all of these folks deploying those same resources that we're using for PPAs towards systemic decarbonization, and ideally moving beyond procurement as the only modality for working on that as a company. Companies can be investing, they can be doing policy work, R&D, changing the way they operate their facilities. There are not recognition systems for the most part inside of sort of sustainability frameworks to give companies the gold stars to do that. So when you're bringing it internally to your CFO and you're saying, hey, I want to invest in this, right now I've got RE100, I've got net zero, but it's very hard to get sort of the sign off to do some of these other things. We need to change all of that. But I think that's ultimately the direction that we likely go, which is just to say, if you want to put a gigawatt scale load on a system, well, it's probably ultimately just more efficient to get the system to 100% decarbonization than to try and do it for your individual point source load. And that is exciting.
I want to add, I think we're almost done. Right?
Almost, yeah. Let's final thoughts from each of you. Yeah.
Okay, because I was just going to expand on what we haven't touched upon yet,
yeah,
which is while we bring all the clean energy to meet these needs, I think there's still this missing gap for us all as consumers to know what we're consuming. And so that takes some standards, some methodologies. I liken it to like a Google Maps or even your airline flights. You can see what is the lowest carbon. Does everyone know? Do they have like a nutrition label of how much energy am I using for a traditional search versus a GPT search, right? It's 10x. Would the consumer make that choice with that knowledge, right? So I think there's, some education, some policies, some standards. We're working, in partnership with the industry to define some of that so that you can also, bring visibility to it, because it could go, exponential if we don't provide some guardrails as well.
Peter, any final thoughts?
Yeah, I mean, I've been working in and around energy for more than 20 years now, and I've been through a few times where it's felt like we were on the cusp of something. And I think this moment feels like we were on the cusp and we have tipped over and the snowball is starting to roll down the hill in like a very positive way. And I think, I really choose to view this load growth slug coming down the pipe here as an opportunity, which I think is unique, at least in the last 15 years or so. And so I'm extremely hopeful that we see a lot of interesting development coming out, particularly, both in the near term and on the longer term, bringing some technologies up the TRL curve a little bit faster, getting deployments of baseload clean, dispatchable clean. There's a lot of very exciting stuff, including, nod to the host, like figuring out how to get storage into houses and doing all sorts of cool and innovative stuff at that sort of distribution, bulk power seam. There's just a lot of really, really cool stuff going on. So it's a very, very exciting time to be working on all of this.
Peter Fried, Jen Huffstetler, thank you for spending your time with us and sharing your wisdom.
Thanks,
Thank you.
Eli.
Thank you so much. We are going to be here for a quick commercial break. It's going to be a fun commercial break. Fingers crossed, so stay where you're at, and we'll show you some fun things to look at right about now. Remember, first Gigaton Salon, first panel, first day. We're ironing out some kinks. Thanks for being here for us and with us. You know what? Let's not do that. Rashida, we're going to work on that. It's going to be awesome later.
Thanks, Trent. How y'all feeling? Oh my gosh, I love the energy. Okay, I was worried we weren't up for a second. Okay, be prepared, because just like the microphones, it's about to get popping. I'm up here talking to y'all like y'all know me. Hi, my name is Rashida Crockett. Rashida Crockett is my name. Hi, I'm waving at you in the back. You're squinting, so I want to know that you see me. I am a member of the 2023 Anthem Award-winning Climate Change Comedy Cohort. You might also know me from this BET Plus show called Bigger, if you're into that kind of thing. But one thing I just learned about myself today is I thought I was someone who had high electricity bills. And then I heard Jen say that all of the data centers are hogging up all the energy. And I was like, okay, well, they probably have higher electricity bills than me. The entire country of Ireland, more than 15% of their electricity bills is from what? Their data consumption centers. Data center consumption. That's just a whole lot of energy that comes from computers and phones, refrigerators. I get it. They have security. You got to protect those things. I see where the power goes. But in order to fix that, we have to have more of an energy supply, right? And how are we going to do that? We've been talking about it all morning. How are we going to do that? Girl, we going to slay that duck curve. Yes. We got to take down that duck curve. So I don't know if you guys saw up front, there's a piñata of a duck. We about to bust that thing open. So if you have any built-up frustration, any anger towards the Koch brothers, because they're actually villains who remind me of the Penguin from Batman, you could take it out on that piñata up there. Who's ready? By a round of applause, who's ready? To the front we go. I love this, Tom. How are you?